Hey everyone! Today we're going to learn about T flip-flop or the toggle flip-flop. First, we need to understand what is T flip-flop, starting off with its definition. T flip-flop, a clock flip-flop whose output toggles. Example, changes to the complementary logic state on every active transition of the clock signal. The device acts as a divide by 2 counter since two active transitions of the clock signal generate one active transition of the output. The T or toggle flip-flop means output will change with respect to input along with clock signal. Next, the logic symbol of the T flip-flop. So the logic symbol of the T flip-flop has the letter T as an input, which represents as the toggle input or the trigger. Also the CLK, which is the clock signal input, and in here the out are the Q and the Q prime, where Q is the present state and the Q prime is a complement of the present state. Now let's take a look at the characteristics table of the T flip-flop. We have here the T or the trigger input and the next state or the Q next of the circuit. So if we have an input of 0, the next state will become Q, and when the input is the 1, the next state will be the complement of the Q, which is the Q prime. Let's now move on to the logic circuit of a T flip-flop. So the logic circuit of a T flip-flop is composed of 4 NAND gates. Here we have the two 3-input NAND gates, and in here we have the 2-input NAND gates. So we have here one input of the two 3-input NAND gates, and is given by the trigger input T and the common clock sign input CLK. And the other one input is from the Q prime, and the lower NAND gate uses Q as another one input. So let's try using this circuit. If we have here 0 as the Q output, or the present state is 0 and the trigger input is 1, what will be the Q prime, or is the Q prime really the complement of the Q or not? So now let's try tracing the circuit. So if the Q is the output, it will be one of the input of the 3-input NAND gate to be 0 here, and 1 as another input. So it will produce an output of 1, and 1 input is from the Q output, so it will be 0. So 0 and 1 will produce a 1. So as we can see, 0Q have the Q prime 1 if the trigger input is 1. So in this example shows or represents the concept logic of circuit T flip-flop. So now if the input is 0 or low, then the Q and the Q prime will be the same. There will be no change in the Q if the trigger input is 0. So it means that if the Q here is 0, then the Q prime will become 0 if the trigger input is low. So it is because the upper NAND gate is enabled and the lower NAND gate will become disabled. So the same present state. So the Q prime will be the same in the present state. Next, as we tried to trace in the circuit, if we use 1 in the trigger input, it will mean that the input is in high. So as we did the q, which is 0, produces the q prime, which is 1, which is true, and which means that the upper NAND gate become disabled and the lower NAND gate is enabled. So what happens here is whatever the Q output will be inverted or become complemented in the Q prime if the trigger input is high or 1. So this is shown in our excitation table. You can see the summary of a circuit here. When the T is 0, the Q and the Q next are the same or remains the same. And if the next state will become 1, and when the trigger input is 1 or high, which means that the Q will be complemented in the next state, and like for example here, if it is 1, it is complemented and it became 0 in the Q next. We have here the summary or simply the equation or the characteristic equation of T flip-flop. So let's try to use this example. So when the T is equal to 0 and the Q prime is equal to 1 plus T prime is 1 and Q will become 0. So 1 times 0 or 0 times 1 is equal to 0 plus 0 times 1 is equal to 0. So it produces a Q next of 0. Next, if we try to use T as 1, so if T is 1 and Q prime will become 1 and T prime will become 0 and Q is 0, so 1 times 1 is equal to 1 plus 0 is equal to 1, so Q next here will become 1. It simply represents the complement or the inverse of the Q when the T or the trigger input is high. So this is our logic equivalent circuit of T flip-flop. So as you can see in the circuit, it is made up of 8 NAND gates wherein we have 4 3-input NAND gates and 4 2-input NAND gates. So it is derived from JK flip-flop equivalent circuit, specifically master-slave JK flip-flop, where we added here the P set and the clear. So if we simulate the circuit and we let the P set and the clear on, so it provides a blinking output of Q and Q prime. So it means that the clock operation takes place. Next, if we off the P set provides an output wherein the Q does not blink and only the Q prime blinks. So it means that the clock operation does not take place. But if we try to on the P set and off the clear, so in contrast, Q blinks and the Q prime does not blink. And lastly, if we off both P set and the clear, both output of the Q and the Q prime does not blink. So it means that the result is inappropriate, wherein Q or Q prime should always be the inverse or the complement of the Q. But in this case, the Q prime does not reverse or inverse the Q. So that's all for the T flip-flop. I hope you have learned something and gained some knowledge. Thanks for watching.